Alrighty then, so it's actually been quite a while since I made the first part of this video. It is now April 2nd, and I have finished up the work on the Charger Buddy version 2.0. Just took me a long time to actually make a video about it. So here we go, and I want to show it to you. But before we get started, I kind of wanted to make a minor correction to a statement that I made in the previous video, or more of a hypothesis, that I wasn't sure what had happened to cause this discoloration around the contactor terminals. And I was thinking maybe there was a dissimilar metals issue going on, or possibly some kind of contaminant like liquid, or too much moisture or something. Anyway, what I realized while I was working with this is that I'm an idiot. As you may know, all of the batteries in my car, all the high voltage batteries, are connected using a special type of washer. Whereas in this particular case, I had used the traditional split ring washers to hold these bolts, or the nut, onto the bolt of the contactor, and to secure these connections. Traditional split ring with a flat washer to kind of distribute the load. Well, that's all well and good. However, this particular unit was mounted in my car upside down, about like so, and it was shaking all the time as I trundled down the road. So over the course of a year, my theory is, my new theory, is that this actually weakened that connection, or backed off the nut just so slightly, in that it caused them to not make a good solid contact between this cable's lug and the contactor, which is bad and causes heat. So I'm guessing it caused enough heat that it melted the insulation around the cable, and possibly was so much heat on the terminal itself that it caused this discoloration. So I'm not sure if this is smoke just from the melting of the insulation, or if it actually was just this got so hot that it discolored it. Luckily the contactors are tested and they work just fine, but I did want to point out that particular discovery. So how do we fix that? Well, just like every battery in my car, I use Nord-Lock washers. So these little washers, again, the camera will not focus on them at all, but the idea here is that these have like a ridged edge around both sides, so they're kind of they'll grip and grab, and then it's a split into two pieces, and those two pieces kind of ratchet together so that they will you can turn them one way relatively easy, but they won't back the other way. And you can check out the video for Nord-Lock, so it's Nord-Lock. There's a lot of really good information on the internet about these things. They're amazing. They don't come loose. They stay nice and strong. And again, I trust my high voltage battery system in my car to them, so why didn't I do that in the Charger Buddy? Well, because I'm an idiot, for one, as I mentioned earlier, but two, for some reason it never occurred to me that the lower voltage, or the AC voltage of the charger, would have, of course, the same issue as the high voltage. Duh. Anyway, so now these are all secured with Nord-Locks. They're really strong, they're not going to go anywhere, and I can rest assured that the connection coming loose is not going to be a problem going forward. Alright, so now we'll go ahead and go over the actual changes made to the Charger Buddy for this version 2.0 update. And I'll just go through it relatively quickly, because we did talk about it before. But basically, before, we had a cable coming in from the car that would be going in hardwired to the charge port on the side of the car, and just went into the white here for the neutral, the black here for the one of the hots, the red on this side for the other hot, and then the green coming in for the ground. So what that did was that connected, again, neutral, hot, hot, and ground, with the hot being separated by these contactors going into this particular little connector. So pretty straightforward, really doesn't do anything terribly fancy, but it's amazing how these little things take so much to come up with. But anyway, so then we have, we've spliced off of that, and we have a 110 outlet, sort of like a 110, that's wired into both of the hot leads for the hot and the neutral. It's normally the neutral and the 110, and then of course the ground for the little green wire. So that goes to this, which goes to a laptop power adapter, and the laptop power adapter is capable of running at 110 or 220, so we can kind of utilize this setup for both types of things that we're plugging into. And I guess it would also work in Europe, but I'm not entirely sure. So, that being said, that's all that. So the big change, or one of the big changes, is that I replaced that cable that went out to the car and just to the charge port with instead a standard NEMA 14-50P plug, which will go into an outlet in the car. So now it's going to have a charge port in the car that goes to an outlet, and then this just plugs into the outlet. Advantage to that being, I can take this entire unit in and out of the car without affecting the car itself. I don't have to unwire the charge port and so forth. And also I can remove this from the equation, plug the charger directly in, because it has the same kind of plug as this, right into the car, and just bypass the entire charger buddy if so desired. So anyway, it's more of a convenience thing than anything else, but you know, does introduce another type plug, another connection inside the car, as opposed to having it being hardwired, but I think it's worth it in this case. So the other big change that I made was, you'll see that we have this white Cat 6 Ethernet cable that's coming in here, and this I'm using for a couple things. One, let's get this out of the way here so you can see a little better. So this is the pack positive and pack negative of the actual battery pack sensor wire. So this is how this voltmeter can actually see what voltage we're dealing with. So that's using solid brown and the orange striped cable of the Ethernet cable. Just for reference, those are on the opposite ends of the Ethernet cable. Again, the camera's not going to make it out, but in a standard Cat 6 Ethernet wiring, it uses the orange pairs on the left and the brown pairs on the right. So basically we've got pack negative on this side, the very last pin, and pack positive on this side, the very last pin. So I've separated them as much as I physically can within this connector, for whatever that's worth. Then I'm using the green cables, so striped green for negative of the, in my case, 19.5 volts, so the 12 volt system, and on this side the solid green is the positive of the 12 volt system, or again 19.5 because of my 19.5 volt power supply. So what that's doing is that's carrying switched low voltage on these two lines, which are coming from the relays in the voltmeter. And those are the same relays that are carrying the positive and negative that trigger this contactor and this contactor. So, like, you know, this red and black wire go to the same terminal, or the black wire goes to 11, and the red one goes to 16 over here. So the idea is that when these two contactors are switched on, we're also getting power sent to this one, and that'll be relevant in a moment. So again, here's our input for our high voltage and our output for our low voltage, and just again as a reference, on the standard Cat 6 cable, the two center pins are blue and blue striped, and then on the outside of those two are the green and the green striped. So basically I've separated the low voltage, 19.5 volts in this case, by as much as I can from each other and from the high voltage connections on the little Cat 6 Ethernet cable. So anyway, that's the way that I utilize this cable. Again, if you plugged this Cat6 cable into a standard computer or something, it would be bad because those two green wires would be carrying 19.5 volts and bad stuff would happen. If you plugged this particular cable into, or the outside connections wouldn't carry any voltage at all, because again, those are the sense wires for the high voltage, so that wouldn't really cause a problem, but you shouldn't do that. Anyway, so that cable comes out here, and I've got it plugged into a little connector that just goes from one Ethernet to another. Standard, off-the-shelf kind of thing. I think I bought that at Lowe's. And then that goes into yet another connector, which is, again, wired straight through. So that wire goes through here and into our Charger Buddy version 2.0 auxiliary box. So this little box, let's see if I can get some more light on that. Yeah, that's a little better. So this little box is very simple. All it is two contactors. These are the Gigavac contactors, GV200s, just as opposed to in the regular Charger Buddy, these are Tyco Kilovac EV200s, I think they are. Anyway, they're basically the same thing, just from two different manufacturers. I happen to have these kicking around when I built this, so I used the Tyco ones. The Gigavac ones are slightly cheaper. They seem to do the same job. And they all work on 12 to 24 volts, which I think incorrectly stated in the earlier video, but it's 12 to 24 volts, which 19.5 is nicely in the middle of, and all you do is supply that to the red and the black, and that moves the little magnetic bar up to make the contactor, and makes contact. That's what they do. Anyway, so back to our Ethernet cable coming in. So on this side, I do the same thing as I did on the other, where I have the striped orange cable going to the negative, pack negative in this case, and the solid brown going to pack positive, and then I've got the green, it's kind of hard to see down there, but the striped green goes to the negative of the low voltage system that just powers the contactor, and the solid green, again, kind of under here, it's hard to show on camera, but anyway, the solid green goes to the positive, low voltage positive, to run the contactors. So basically these two contactors will engage whenever these two red and black relays trigger, giving us power to that little guy. So in this way, both the contactors in the original unit and the contactors in the auxiliary unit are both going to turn on and off at the same time, triggered by exactly the same relays of the JLD 5740 voltmeter. Okay, so that's it going on for the white cable. So what about the red and black? So this is the red and black coming in on the side with the white cable is our pack connection. So these are the special, I'll turn them up here, I believe these are 120 amp connectors, so they're capable of carrying a lot of juice, and I'm only putting 40 amps through them, so they're definitely oversized, plus these nice big thick cables are the same cables that I use to carry current from the battery pack at the front of the car back to this box. So again, this side, battery pack plugged in, which goes into here, and that's how we get our pack measurement of negative and positive, so we know what the voltage is of the pack. On the other side of the switch of the contactors is just positive and negative going out to a very similar or identical connector on this side, which is our positive and negative going into our charger. So this connects the charger to this side, the battery pack to this side, and now we have a way to physically disconnect the charger as triggered by the relays in the Charger Buddy. So now the charger is being unplugged from the wall by these two contactors, unplugging the hot leads anyway from the wall, and then on this side we have the same unit, but now disconnecting the charger from the battery pack. Now, why is that important? Why would that actually be of value to anyone? Well, the charger is very capable of being connected to the battery pack at all times, doesn't seem to be a problem. However, in my particular case, I've got a large, older Manzanita PFC50 charger that, when it's plugged into the battery pack, works just fine, but makes this really obnoxious whining noise when I drive the car. Whenever I'm pushing power through my Soliton EV1, my Evnetic Soliton 1, rather, EV1, where they come from, I don't know. Anyway, Evnetic Soliton 1, whenever I'm pushing major amounts of current through there, I get this high-pitched whining noise coming out of my charger if it's plugged into the battery pack. So all I can figure is it's like a capacitor or something in there that's just, you know, running minor amounts of current through it or something, and it's causing it to complain. It doesn't seem to hurt the charger. The charger seems to work fine afterwards, but it's ear-piercing, nails-on chalkboard bad, and it's just, you know, I have to physically unplug the charger every time from the pack. So not only do I have to unplug it from the wall, but I have to unplug it from the pack every time, which is just inconvenient. So anyway, this little box will automatically unplug the pack anytime that these two contactors are disengaged, which happens if you unplug this from the wall, or if it hits the voltage, the high enough voltage for the battery pack. So it's kind of like a 2-for-1 deal, and once again, even if it's disconnected, so the charger is that way, and the battery pack is that way, so the battery pack always remains connected to this box, which is how we get our sense leads to tell what the voltage is, but it'll disconnect the charger whenever the charger buddy decides to unplug the charger from the wall. So I think it'll help. I think it'll resolve my particular issue, and again, this is completely disconnectable from the car. As you saw, it's connected with this little Ethernet cable to the charger buddy unit, and you know, this unit can just be unplugged with those nice Anderson connectors, Anderson 120 amp connectors. So there you have it. That is the joy of the Charger Buddy version 2.0. Also, while I was at it, I made another adapter because I had harvested mine for parts. So this is a 220 to 110 adapter. And so using the Manzanita specifications in their manual, I made this particular adapter. And so what's interesting about it is, and why it works with this whole setup, is so we've got the blades here, and the larger blade, I believe, is on the right hand side. Yes, so it doesn't show on this connector. This particular connector I got from Lowe's only has the one. They're both the same size, but sometimes they have a larger blade on this side, kind of like you can see on my outlet there. On the left hand side is smaller, and the right hand side is a larger blade. Anyway, so I believe that is the neutral, is the bigger one, or the right hand side, and this one is the hot, and then of course this is the ground for the little guy. So what's cool about that is how it's wired to this is that the neutral goes to one side, and let's see if I can figure this out by context. Let's see. Yeah, so the neutral goes to this side, and the hot goes to this side from here. So neutral is the bigger one, which goes to I had to turn it upside down because it's kind of like inverted. Neutral here. So neutral to neutral, hot to hot, and then ground goes straight through to ground. And then the neutral lead here is not actually used at all with this adapter. It's just left empty. So by virtue of that, when it gets to here, we end up with the red hot lead is actually neutral in this case with the adapter, with the converter, and then we have the neutral, which goes to here, conveniently, to our actual plug. So basically it creates the same setup for 110, and this will still work on 110 as well. So we can kind of test that if you'd like. It's a little awkward to plug these big heavy cables in while holding the camera, but so we're just going to plug the charger buddy into this little adapter into the wall. And you heard the click. That was the contactors engaging. Both the contactors over here, both of these guys, as well as both of these guys. And if we carefully turn this over, we can see that the meter is all lit up and everybody's happy. So everything's got power, everything works, and so this outlet is now live with neutral hot, or vice versa. Again, I always get them flipped over when I'm looking at it upside down, but one side's neutral, one side's hot. This one is not connected to anything via the adapter and the ground. And the charger, the Manzanita chargers will work with that exact setup at 110. That's how they determine that they're at 110 volts. But yeah, so that's kind of the magic. And if we unplug this, we will hear it disengage immediately. And so that's the other feature, is that when you unplug the charger, unplug it from the wall, that we get an immediate disconnect of both these contactors and these contactors, because there's no more power going to the 12 volt adapter, or 19.5 volt. Anyway, so I've rambled enough, I think. One last point I will make up before I go is that, well, for one thing, you may have noticed me flash this by. This is just a Anderson 120 amp connector to, I think this is the 50 amp connector. This is the type that normally ships on the charger, like comes on the Manzanita chargers. I beefed mine up to these guys just because it doesn't really need to be this large, but that's what I ended up using. I like the nice secure fit of them. They fit together very nicely, and once you snap them in place, they're not going anywhere, and they are capable of carrying more amps. Bigger, that's always better. Oversizing, always better in this case, than the little Anderson 50 amp connector. So anyway, this is an adapter so that when I send my charger back for repair, or if I'm going to loan it to somebody who has a standard Anderson connector, they can just plug it into my charger, or in this case, the charger buddy, and it would just work. So anyway, that's what that's all about. Last but not least, I have updated my diagram to include all of the changes that have been made. Spent a lot of time on this. I'm not an artist, and Microsoft Paint and I did some fun things. So I will have a copy of this particular diagram in high resolution, or as high as it is, PNG format up on my blog. Just because looking at it in the video, it's probably really hard to read anything with my blurry little camera. But anyway, everything is on there, it's all documented, and hopefully will make life easier. I'm going to go ahead and get this put back together, and then we'll get it installed in the car and show you how it works. Now that I have the charger buddy all reassembled, you can see this is the final setup that will be going in the car. I just wanted to point out something, that the auxiliary unit here that is used to disconnect the charger from the pack is entirely optional, of course, as mentioned earlier. However, you could easily use the charger buddy as is, with all the wiring intact, and simply change this Ethernet cable that's on this side to, instead of going in and touching both of those contactors, it could just go into a connector like this that connects to your battery pack for the high voltage positive and negative sense wires. So as long as you have those two sense wires on those two outer Ethernet cable wires, this will work exactly as it did before, without the auxiliary unit at all. So if you don't have a need for that kind of thing, you could easily just not have this unit, which means you'd be saving, the cost of two contactors and some plugs, plus the box, if you don't need it. So anyway, I just wanted to point that out, that the Charger Buddy is not dependent on the auxiliary module. It's just needed in my particular case due to my desire to disconnect the charger from the pack. So anyway, fun stuff.